like this particular slide here, which I hope you can all see. Sometimes when we show this in a room, it's not quite this dark, it's not possible. But there's 3 panels here as I go across this way. There's a panel here with a root tip. There's no treatment on that, it's just growing in a growth medium. That happens to be a model plant. This is not any, that's not particularly important, but I just say it for integrity reasons. This is a root tip which has been sitting in a very small amount of great land. It's kind of trying to be adjusted to the amounts that you might see following an application in the real world. And here's a 5 times higher dose. The important things I think to notice is that without the treatment, the root tip has very small, short and a smaller number of root hairs, whereas with the treatment with great land, either at 10 microlitres or 50 microlitres, there is a much more prolific set of root hairs on the root tip. And I think you'd probably agree that the one with slightly more has slightly more root hairs than the one with the lower dose. So there's a bit of a dose effect as well. But the difference between those 2 panels and that panel, I think, is profound. I don't think there's any argument about that. We could debate whether the 2 right-hand ones are different, but I think we can easily agree that the left-hand one is very different to the 2 right-hand.
So is that just the application rate? How much?
Well, this is in the laboratory, and we've tried to match that to the application rate in the field. That's not easy, but it's a very small amount in a large-ish volume in the laboratory.
I'm just thinking as a miserable bastard. I'd be using a little bit because that tiny little bit gets you that much, and you put that much more on to get that much.
And I would too. I would too. Yes, I mean, writing the check out, I'd be going with this, not that. But you know, from a scientific point of view, we like to know there's a dose effect. And there will be a point where you'll get no greater effect, so then you'll be wasting money. And there'll be a threshold where you don't see an effect because you've got too little. We haven't found that, but that will be true. This one's a little bit more difficult to see, but I think let's just go through it logically. Here is the control dish. Nothing's happened there. Here's a dish that has had, as best as we can, extract the normally occurring soil microbes from soil. And they've been added there. Here's a dish, so that dish has soil microbes on top of that, if you like, where there's no treatment. This dish has that plus great land. And this dish has great, now this is before we changed the name to Great Land Plus and we were using it at a slightly higher application rate because it was less concentrated. This dish has both the soil microbes and the great land. So if you like, this dish is as close as possible to the real world in a laboratory setting. You're applying great land on top of the existing biology in the soil. I think it'd be fair to say, and certainly from my point of view, because I'm a bit closer, there's much more prolific root development here and here than there is here. There's also much more above ground, if you like, the green stuff, above ground plant than here and here. And there's not a huge difference between those 2. There might be a little bit more green stuff, but the root structure I think is about the same. So here we've got a good demonstration of enhanced root structure, and we've got an enhancement in the above ground plant matter following the application of great land, or as it would be today, Great Land Plus. And the effect with the existing soil microbes might be slightly more profound above ground. We also wanted to see if it was important to have that mix, or as I've said before, there was lactobacillus in it, and there's an acetobacter in there as well. We wanted to look if there was an effect by having that consortium, a group of microbes, as opposed to having each one. Remember I talked about the codes we have. We have these codes here, so we've used them individually, and then we've used them collectively. In short, individually you get a growth effect, weight, goes up a bit and up down a bit, but collectively you get a much more profound effect. So we've demonstrated that there's good reason to have the mix in great land. We've demonstrated that great land itself can affect the way the root structure is developed, and it affects the way the plant grows above the ground. And all of these are positive effects. Once more, we're looking at Lucerne here. I think it's better to first of all, I won't leave that alone and I won't leave that aside. Let's look at the two right-hand panels first. These are grown in little rock wool tubs, no treatment or control, great land. I think it's fair to say that the roots sticking out here are longer. There seems to be more of them sticking out. Perhaps there's a bit of an effect above ground too. A little bit more difficult to see there, but I think there is slightly more above ground structure there. And over here, this one is really just shown to show how much more profound you can find these root growth. The root structure is much longer than we ever saw in any of the control. Clearly this is only one set. We would have had hundreds of these tubs in our own greenhouse. We have our own greenhouses up in Queensland where we do this work. So again, we're seeing this manifesting not only in a petri dish in the lab, but now in a greenhouse. Plants grown in a greenhouse. Then we go and do these studies in the real world, if you like, and this was done independently by a crowd called Ecologic for us. We've got grams on this side on the y-axis, and on here we've got the measurements of the different parts of the plant. Again, we're looking at Lucerne here. Treated as the yellow bars, untreated as the blue bars. We've got just the above ground mass being measured, we've got the root mass being measured, and clearly if you add those together you get the total. And you can see that all of the yellow bars are taller than the blue bars. There is an effect from the use of great land that is positive. There's more of the plant material produced, which would ultimately convert into more dry matter. Then we go and look at a few more, if you like, a few more real world studies. We've done work in Lucerne at Forbes, Shepparton in Victoria, and Gambia in South Australia. Split paddock, paired paddocks, we've done those. This is at the, currently we're at 4 litres a hectare with Great Land Plus. 10 litres a hectare was the last application rate of Great Land. So we've gone from 10 litres a hectare to 4 litres a hectare now. As I said, that's a concentration effect. There's nothing different in the product. It's just the way we make it. We're just better at it. Simple as that.
So how are you delivering that?
Spray.
Just the boom spray?
Boom spray. And it's the particles. Yeah, some people do it aerially, and the particle size doesn't block the
So is
juice.
it affected by the moisture that's on the plant at the time?
We recommend that it's sprayed out just prior to a rain event. That's difficult to control. Maybe not. Yeah, today would be a great day for it if you can get the tractors on. We recommend that it's not done in the middle of a hot, dry day. Better in the morning or in the later evening. If it's particularly humid, that's fine. That's really good. But a hot, dry, sunny time is not the right time to apply it. If you can get a rain event, fantastic. But remember, this is being diluted. So when I say 4 litres a hectare or 10 litres a hectare here, it doesn't matter. This is being diluted in water at a rate of about 1 in 10. 1 in 9, 1 in 10 doesn't matter. Roughly 10%. So you're putting out a lot more water to get that flushing effect, if you like. The rain event is even better. But going through all of that, we're looking at harvested seeds and harvested hay, if you like, and we're consistently getting a 16 to 18% lift in productivity. In one trial here, we got a 40% lift, which is fantastic, but I'd say that that's a bit of an outlier. I'm really comfortable with the 16 to 18%, and possibly would say if we did more, we might just settle on about a 20% improvement. Again, these studies were all done independently of us.
So that's like one application
No, good question. The recommended application is 3 times a year.
So about now, spring, what else?
Yeah, well, it depends on the location. You know,
Is it only for Lucerne or legumes?
No. We just did the study on Lucerne. Any pasture at all. Any pasture at all.
If I could just ask a question, obviously those cows, if they're grown Lucerne, they've probably got pretty good soils with reasonable amount of phosphorus and stuff in them. How does it go where you go from there to like an average beef farmer in Bega who's got reasonably poor soils with pretty low phosphorus? How does it go on them? Has there been any trials where it on poorer quality soils?
There's been quite a lot of work done by agronomists on soil types that vary a lot, and clearly across, not just from here to Victoria to South Australia, things change a lot right across Australia. My view is you should address the soil a little bit in the first place. If you've got a deficiency in something, that should be addressed anyway. That would just be good farming. That's nothing to do with our product. That I think you should do.
That's what I'm trying to find out is, how much do we really need to lift our poorer soils up before we start using something like that?
I think if I'm going to say I want to give you an effect, I think that there's 3 things you've got to look at, and you'll get this from any soil test that Danny might do for you, any other agronomist might do for you. But there's 2 things that are really important. First one, pH. Try to bring that up to 6.5, 6.8, 6.2 is probably okay. So if you're really acidic soils, you've got to address that. Because it's not so much, these guys, I talked about before, these guys are happy in a low pH environment. Not that you want a low pH environment, they're happy in it. But the pH is going to affect the soil chemistry so profoundly if it's acidic compared to neutral. Yeah. Regardless of what we do, it's just changing your soil chemistry. Secondly, and really importantly also, is organic matter content. Organic matter content is vital.
I think all our soils here are quite acidic. So, we have this, Dan, you're probably better than this.
Yeah, they are. You're talking water, 6.5.
Yeah.
Yeah, so we're probably around 5.5.
Yeah, so that needs, efforts need to be made to lift that up. I'm talking about, I want to give you an effect. Yeah. I want to give you an effect. I want you to lift that from 5.5 to north of 6, if that's possible. Certainly as much as you can.
Is that going to be economically viable, Danny?
Well, you get to 6, okay, probably. You go to 6.5 would be a fair cost.
Yeah. Well, I think at 6 you're sort of getting, I'm comfortable at 6 plus.
Yeah.
I'm not really comfortable at 5.
Yeah.
But then probably no one is particularly comfortable at 5 anyway, but you've got to live with what you've got. I get that.
Yeah.
The second thing is organic matter content, and that's got to be good. So, your soil carbon's got to be up there a bit.
So we're going to use our conventional fertilisers to get it up right so we can use yours.
I wouldn't have said that. I would have said you could probably...
No, not conventional.
You could probably spray compost, would be a good way of, another way of getting your soil carbon up.
Fish meal.
You've got some good recipes yourself, so we could have a terrific partnership here. I'm sure your soil carbon's getting up there too with your practices.
But it wasn't always there.
No. But these are, as I said, I'm wanting you to get an effect. So I'm going to say, let's do the soil test. Let's see what the pH, Danny's probably got them. Let's see what the pH is. Let's see if it can be lifted a bit. Let's see what the organic matter content is. If that's okay, let's go. The third one is cations, but I'm less worried about those because they kind of can be addressed.
I don't think my pH has changed much at all over the time I've been using Danny. I don't think we've seen a real change in everything else that's gone on. And we haven't looked at that. I've been too miserable because I spend the money on the line. It's just interesting.
Well, you might be just at that borderline area with your soil pH where the chemistry is not being affected in your soil. As I said, it's not going to affect our product. I think it's going to affect the size of the effect. Let me put it to you this way. If you were growing lucerne and you had your low pH, but your organic matter content was right up there, I don't think I'd be as robust about my 16 to 18% numbers if your pH is low. I would probably say, let's hope for 16%, but because you've got a low pH, and I don't know whether it's affecting the soil chemistry, you might not quite see that. You might see 12% or 14% or something like that.
What sort of organic matter levels?
Two, north of 2.
Yeah, oh, that's right. Yeah, most of ours around here in that 2.
Oh, yeah, I would have thought everyone's past you and they're recycling their own organic matter content, organic matter, sorry. But look, there's easy strategies to deal with that anyway.
The other question I had was, you wouldn't think so at the moment, but normally Bega is a bit of a boom and bust. We get, big lots of wet.
Certainly doesn't look like busting at the moment.
And then a fair dry. Now, how does that sort of up and down moisture level affect?
That's a great question because I'm going to address that in a couple of different ways. One is what's really important in terms of application timing is soil temperature. And I'm guessing your soil temperature drops pretty low in winter. So forget it at that time because everything's gone to sleep. Wait for your soil temperatures to be, 12 degrees would be comfortable. Even north of that's even better. Don't go into if your soil gets down to single digits, which I guess it does in the depths of winter. Yeah, forget it. Just forget it. So everyone that we talk to pretty much doesn't do it over winter, and they might have different reasons for doing it because they can't get onto the paddocks. They'd only be able to do aerial spraying. But soil temperature, forget it. If it's low, don't even think about it. Second one is if there is abiotic stress, low moisture content in the soil, through the application of this, and you'll find this probably within the 12-month period or 18-month period, your pasture will be much more tolerant to low moisture conditions because they've got that the grasses have got a more developed root structure and they're just able to find the moisture that's there. So if you find the soil's drier than normal, and particularly, certainly around where Mel comes from in northern Victoria, once it turns dry, the grasses go from green to yellow overnight. But the ones that have been treated with Greatland will hang on for an extra 2 weeks, 3 weeks. And we've got plenty of stories where neighbours have been driving down the road and saying, why are your paddocks green and mine are yellow? And that's the root effect. The other thing about the root effect, particularly if you've got a diverse pasture, is that you'll have root development going on at all, shallow and deep. And that helps prevent plugging from the animals because you've just got a better soil structure. So the animals might dig into the soil pretty deeply, but not as deeply as they will if you don't have that well-developed root structure. And that's a common finding that farmers will tell us about. I can run my animals for longer on this pasture when it's wet. So both ways, when there's a kind of a surfeit of water in the soil and when there's a low amount of moisture in the soil, this has a positive effect. And if you've got that green tinge going, then you've got feed going for a bit longer. Did that answer the question?
Yeah.
I kind of was a roundabout way to answer it, but yeah, I hope that answered the question.
Yeah, I think pH is probably the thing that we'd have to really look at.
Yeah. Well, you could be marginal at I don't know the pHs around here, but if it's 5.5, you're probably marginal, and that's okay. But I'm saying, as I said, I wouldn't be as robust with my 16 to 18% benefit. And it's not going to work all the time. There will be conditions where you just don't see that. Even if you get the pH right and the organic matter content's okay and all that sort of stuff, I'm sure there'll be, because this is biology, we're not talking about a herbicide where you get an effect straight away. It's not like that. And that's why 3 applications a year, and I would say, you've got to make a commitment to this. If you're going to address the soil, which is going to cost some money, then I do that on the basis that I'm committing to this sort of approach, a biological approach for a period of time. Because it's not going to just happen overnight with one application.
And you're not going to correct your soil pH overnight either.
No, this is a program. So that's a discussion you need to have with your agronomist. Okay, how much is this going to cost? We're going to do it this way, that way, and the other way. All the other things I've got to do, I've got to address that. Then I've got to put this out. That's putting it out's going to cost, unless you've got your own spray rig. That's going to cost a bit of money too. So you've got to think of it like a program.